This conference will now be recorded.
Okay, so good evening, friends. So in today's session, basically, we are going to talk about the Spark architecture. As part of today's session, we are going to talk about what is Spark and its futures, and then we will talk about the node internals. What is node? We already discussed as part of the training. Node is nothing but a one server. One server is nothing but one computer. Okay, so what all things we need to learned as part of the node we will discuss. Then we will talk about Spark architecture. So in Spark architecture, one of the main component is driver program. Then we will talk about the cluster manager, second component. Third and most important component is worker node. Then inside worker node, we will have a thread is called a executor. Inside executors, we will assign the cores. For each executor we assign the CPUs, right? So that particular part, the task, how we will assign to the executors, we will discuss that. Then we are going to talk about cluster sizing examples. Okay, so whether, let's say you have 250 GB, like let's say 128 GB memory and 64 cores. There is a one mission, you have big mission, big computer. And other examples are, let's say you have 32 GB memory into four virtual missions you are taking. Each virtual mission is 32 GB. Now 32 GB into 4 is, again it will become a 128 GB of memory, and each computer will have 16 cores. 16 into 4 is 64. So which means that you want to take a single computer which is 128 GB memory and 64 cores, or you want to take a four small computers. So which one you need to choose in which scenarios? That cluster sizing examples we will discuss. Then we will talk about life cycle of Spark application. Let's say you submitted this your Spark application. Till end of the Spark job, what all things are going to happen step by step we are going to discuss as part of the life cycle of Spark application. Okay, let's start with the what is Spark. So we all know, right? What is Spark? We all know, right? What is Spark? What is Spark? Yes. So Spark is an open source. What is meant by open source? So we have different softwares which are open source, right? So what is the meaning of open source? Open source meaning you can basically take the code that is developed by the Spark developers. Okay, whoever developed the Spark, they developed the code and given to you. You can customize that. You take that code and you can change as per your requirement. You can make the change. So that is nothing but a open source software. So Spark is also one of the open source software which is developed by UC Berkeley RAD lab in 2009. Okay, next. It was released to the public in 2010. Spark has grown in popularity and is used through the industry with an unprecedented scale, meaning unpredicted popularity Spark has attracted. How it has got that much popularity? Because the speed in which it will execute the Spark jobs or the data processing, which make industry to adopt the Spark very quickly. Okay, next. Apache Spark is an open source distributed general purpose cluster computing framework. So there are a lot of things are there. Apache Spark is an open source. Open source we already discussed. You can take the code and you can make the modification as per your requirement. Distributed. What is meant by distributed? I have a 10 chocolates. I can give, if I have a one person, I can give all the chocolates to one person. But let's say there are four people I have. What I can do? I can distribute. Okay, let's say I have, let's say 20 chocolates I have. I have a four people. So can you tell me how many chocolates I need to give it to each person? I have four people. I have 20 chocolates. So each person will get a five chocolates. So this is a distributed. Why? So when this distribution will come, When you have a multiple people, if it is a only one person, the distribution word will not come into the picture. So distributed meaning we have a multiple people. So in this software terminology, we need to talk as a multiple computers we are going to have in the Spark. Okay, multiple computers we are going to have in the Spark. Now what we are going to do here, we have taken an example of chocolates distributing to the people. So in the data processing terminology, what we need to do is, we need to say is, we have multiple computers, we need to distribute the data across all the computers. Let's say I have 100 records, I have a 100 customer details. Okay, first customer is 1 Rama, second customer is 2 Krishna, third customer is 3 Sai, like that. So 100 records I have a 5 computers. Now I need to distribute these 20 records between these 5 computers. So each computer, how many records it will get? Each computer, how many records it will get? Why nobody is speaking?
4 records.
So I have 100 records. There are 5 people. Sorry, 5 computers. Now each computer will get how many records?
20 records. 20 records.
20. Okay, 20 records. Correct. Now, so each computer will get 20 records and it will execute. See, this is when we are discussing. But in the programmatically, the reality is maybe 1 or 2, like maybe first computer may take 22, 23, second computer may take 21, 20 or 19. Okay, so the even distribution means that is the even distribution. There is uneven distribution. Uneven distribution means you have a 5 computers. For first computer, you are going to give a 70 records. Okay, you are going to give a 70 records. Next computer you will give some 8. Next computer you will give 7. Next computer 8. Next computer 7. So 70 plus 30, it will become 100. Got it? So this is uneven distribution. This is one of the problem which we may get it. So, but from Spark 3 onwards, this is automatically resolved by Spark developers. Okay, but we will talk about what kind of problem. This kind of a problem is called a skewness. So in interview, people will ask you, what is meant by skewness? Whenever there is an uneven distribution of the data, so the execution of the, like simple. So you have 100 chocolates, there are 5 people. If you give 70 chocolates to first person, he will take a lot of time to eat all the 70 chocolates, right? Similarly, if you give 70 records to the first computer takes a lot of time to execute. So meantime, what happens, other computers already completed the job as it received less records, and it is idle. Idle means it is just sitting like that. You are not using these resources properly. Got it? You are not using these resources properly. Everybody got it? Till here? That is the word.
Yes.
That is the terminology of distributed. Now, general purpose cluster computing. What is the meaning of cluster? Cluster means group. Cluster computing meaning compute servers you are going to group to distribute your workload and execute parallelly. I'm repeating again. Cluster computing meaning group of compute nodes you are grouping. You are basically joining to execute your data or to execute your jobs parallelly and to finish the job in a less time with a low latency. Clear? Next. Spark provides an interface for programming entire clusters with implicit data parallelism and fault tolerance. What is data parallelism? Data parallelism meaning now I have 100 records I distributed between the all 5 computers. All the 5 computers are parallelly reading the data, parallelly applying the other transformation, maybe filter, join, union, something else. Got it? That is the implicit data parallelism. So Spark has implicit data parallelism means you no need to configure anything. Automatically Spark can be able to parallelize your jobs. Okay, next. What is fault tolerance? Fault tolerance means you have 5 people. Okay, so while executing your job, if one of the person is ill, you can just ignore that person. Okay, maybe you can replace with another person, right? Similarly, in the this Spark cluster also, if any computer is not doing well, if any computer is not doing well, what you are going to do is you are going to terminate that particular worker node, and you will replace another worker node, or you may restart that particular worker node based on the cluster manager that you are using. There are different cluster managers we have. So based on the different cluster manager, some cluster managers will restart, some cluster managers will complete terminate and replace another computer. So anything may happen. Okay, meaning there is a fault, one of the computer is down, there is a fault, but still you can able to tolerate. You are not going to lose any data here. You're not going to lose any data because Spark will maintain the execution, or you can say the flow of transformation. It will record. That is nothing but a DAG. Okay, so, or you can say lineage. DAG will have complete information, lineage will have just that particular data, how to calculate that information only, limited information we have in lineage, full information we have in the DAG. Okay, so using this lineage and DAG, we can able to go and re-extract the data that we lost because of this computer is not healthy, this computer is down for some reason. You can just still you can go and get the data from the maybe from the source, or intermediately somewhere you have captured the data into the memory. From there you can able to get it. So anything you can able to do. Okay, but ultimately anything happens, any fault is there, you can able to tolerate. Next. So Apache Spark is a fast real-time data processing framework. Why it is a faster? It will process all the data in the memory. So intermediate result, it basically cache it in the memory. And if you want to make any result or one of the data from result, you are keep on reusing, okay, multiple times, you are basically reading, writing, a lot of things you are doing, then what you can do, you can cache it in the memory so that it will not be recomputed. So it directly read data from the memory, it will be very faster. Okay, so the data processing is faster, meaning whatever data is coming, live data, that you can able to process it using such type of tools. So Spark is very faster as it is using the memory, in memory. So we can able to achieve the real-time data processing also using Spark. It has been proven to be easier and faster than Hadoop MapReduce, because Hadoop MapReduce uses the hard disk, but whereas Spark uses in memory. So that's why Spark is faster. Next, in the era of big data, practitioner needs more than ever fast and reliable tools to process real-time data. That is nothing but a streaming of data. Okay, so that's why most of the clients are adopting this Spark, and we have a lot of demand for the Databricks. It allows high-speed access and data processing, reducing times from hours to minutes. So basically, if you take a MapReduce, that is Hadoop, it used to take like if it is taking 10 hours, if you use Spark, it basically takes 2 to 3 hours. Okay, basically theoretically they'll say 100 times faster, but reality is maybe it is just faster compared to your Hadoop. Maybe 3 to 4 times it is faster. Okay, you can experience live. Okay. Next. So now let's talk about the computer. Okay, one computer, if we take, what all things will be there in the computer. Okay, this is the computer, whatever we discussed as part of a training session. Okay, so there are 16 cores. Core meaning CPUs. Okay, 16 CPUs are there. Memory 64 GB memory I have. 1 GB I'm leaving for other process, background process. Core also, one core I'm leaving. Now I am, so what happens in this node is, this is a simple computer. How you are purchasing a computer from Flipkart or Amazon, you will get a brand new laptop. Now in that laptop, let's say you need to install the Java. If you want to run any Spark job, you need to install the Java. So when you install Java, what you will have in the Java, what you will have in the Java, JVM, Java virtual machine will be there. Okay, so in that Java virtual machine, what you can do is, using on single JVM, you can able to run multiple executors. 1, 2, 3. Total how many executors I'm running on a single JVM? 3 executors. Meaning all the resources that you have in this computer, you are going to divide into 3 different parts. Now, what is the use of creating multiple executors? What is the use of multi-threading? What is the use of multi-threading?
Parallelism.
Multiple processes can be run at a time.
Yes, so let me give you some example. I just have prepared some data in Python. See, there is a threading module I just imported, and what I'm doing is I'm passing some number. I'm just iterating through that number. This is a cube function. This is a square function. Okay, so those two functions I'm calling at once using the threads. See, thread. Okay, T1 and T2 are the two different threads. Both I'm starting at once. Now what happens? You see. empty.py. Okay, go to desktop, empty.py. Execute. See here, square is running, cube is running, square is running, cube is running. Why? There are some squares, there are some cubes, because both are running parallelly. That's why some squares are printing, next cubes are printing, next squares are printing, cubes are printing. Next time if you execute, different result. Next time if you execute, different result, because both are independent jobs. Both are independent jobs, but I have only Python only one time installed, only one PVM is there. Okay, Python virtual machine only one is there. Similarly, when you install a Java, there is only Java virtual machine, only one. But on same JVM, you can run a multiple threads. Each thread is nothing but an executor. So now you see, if I'm not using a executor concept, what happens? I'm just commenting this. Let's say now I'm calling this function in Python. I'm just calling this function. If you're not using threading concept, what happens? Let's pass some value. Okay, now I'm just saving this and I'm just running. What is happening? You do 100 times. You do 100 times. First it will execute cube, then it will come to the square. Meaning you are running in a sequential, not parallel. But if you use threading concept, what is happening? Both the functions are independently running in a two different processes, but the background it will use same PVM, Python virtual machine. See here. Similarly, what happens is here in this computer we are going to install a Java. When you install, you will have a JVM. That JVM, on JVM we are running a 3 different threads. Each thread is nothing but a one executor. Clear to all of you? Now, what is the total computer capacity out of 16 CPUs? I have taken only 15 because one I need to keep it, otherwise system will get stuck if you use complete resources. Okay, so out of 15, 5 cores I assign to here, 5 cores I assign to here, 5 cores I assign to here. Out of 64, 63 GB, 21 GB here, 21 GB here, 21 GB I have assigned. Okay, now when you have a 5 cores, remember, so basically 5 cores means 5 tasks. Okay, 5 cores means we will say 5 tasks. Now the question is, how many partitions should run per task? Okay, see, one task is nothing but one core, right? One CPU. Now the question is, how many partitions should run per core or per task? That configuration also you can able to set it. Let me show you. So you see your clusters, adaptive core execution. I'll tell you. See, there is a configuration here. You can see. So the min partition size, the minimum partition size is 2 into number of cluster cores. 2 into number of cluster cores, meaning per core we are submitting the 2 partitions, 2 into number of cluster cores. So in this node, how many cores we have? We are basically trying to use a 5 cores here. So 5 into 2 is 10 partitions I can execute in this executor. 10 partitions I can execute here, 10 partitions I can execute here, meaning how many partitions total I can execute here? 30. See, 2 here, 2 here, 2 here, 2 here, 10. So 10, 10, total 30 partitions I can execute at a time. At a time, 30 subthreads, you can say, okay? 30 partitions will execute. Let's say you have, let's imagine you have 300 records. Now, if we create a 30 partitions, each partition approximately 10 records it will have, meaning each 10 records will be executed by here thread. Okay, here, this one. Got it? Everybody clear here? Everybody's clear? Okay, now.
Yes.
Spark multi-node cluster. Let's say multi-node means, as we discussed, we will not have a single computer. Okay, we will not have a single computer. That's why it's a distributed, because it will have a multiple. Let's say here we have taken example of 64 GB and 16 cores. We have created 30. We are able to execute 30 partitions. Like that, if I take a 2 computers, I can able to execute how many partitions? How many partitions I can execute if I take this one, 2 computers, 60 partitions I can execute. Clear to all of you? Any doubts still here?
No, this is clear.
Okay, let's move. Spark architecture. Okay, so in Spark architecture there are 5 parts. One is driver program, cluster manager, worker node, executor, and task. Okay, I'll clearly mention. So theory we will talk about it later, because theory is not that much important. Let's focus on the diagram. Okay, driver program, where we will create a Spark session or Spark context. I have explained you in the session what is the difference between Spark session and Spark context, when we need to go for the Spark session, when we need to go for the Spark context, all those things we discussed. What happens in Spark architecture is, first you submit a application code, that is a step 1. Step 2, it create the Spark session or Spark context, meaning it will initialize the communication between the computers in a Spark cluster using the Spark session or Spark context. Now, this particular driver program will ask the cluster manager to launch the worker nodes required resources. So cluster manager, as per the request, it will launch the worker nodes. Okay, so 30 total, 60 partitions you can able to execute. So once you requested the cluster manager, now cluster manager assign the worker nodes. Now driver program will establish the communication with the worker node. Driver program will establish the communication with the worker node, and it submit the task on the worker node. Okay, how to create the task? How to create the task? Task is nothing but a partition. How the partition will be created? Okay, so when you create a RDD, when you create a data frame, automatically partitions will be created. So partitions high level, you will have stages. Stages high level, you will have a job. Job high level, you will have a application. Clear? So here what is happening? Driver will submit task on the worker nodes. Workers will execute the task, and it returns result back to the driver program. It returns result back to the driver program. So driver program will give the result to the user, end user, and that's all. That is the Spark application ends here. I'm repeating again because it's very important. Today's session is completely focused on the Spark architecture. Step 1, user is going to submit the application code on the driver program. Step 2, driver program, it will initialize the Spark session and Spark context. Step 3, driver program will ask cluster manager to launch the required resources to execute the task. Fourth step, cluster manager will assign the required resources to the required resources it will launch. That is nothing but a worker nodes it will launch. Fifth step is driver will establish the connection to the worker node. Okay. Once the connection is established, the sixth step is it will submit the task on the worker nodes. Okay, it will submit the tasks on the worker nodes. Worker will have executors and task as we discussed. It will have some resource capacity, right? Memory, the cores will be allocated for each task. So this driver will give the task, that is nothing but partitions, to the worker nodes. Worker nodes will execute the task, and seventh step is it returns result back to the driver program. What driver program will do? Step 8, it returns result back to the result back to the end user. That is step 8. Step 9 is application will be closed, meaning the job is completed, application execution is completed. Whatever code you have submitted, the execution of that particular application code is completed using this Spark cluster. Any questions?
One question I want to ask, Malaya.
Yes, please go on.
So for the how will it decide the number of partitions? Like cores, I understood how partitions, but how the partitions are there?
So here you need to understand two things. Your question may be two ways. One is how the partition is decided, meaning like which records will go into which partition and how it will create the number of partitions. That is one question. The other question is how you will decide the number of partitions. Okay, so how we will decide the number of partition is the default partition is if we have a two computers, 16 plus 16, 16 plus 16, how many cores we have? 32. 32 means by default it will create a 64 partitions. By default it will create a 64 partition. Clear?
Okay. No, this I understood. Yes, this I understood. I'll follow up one more question.
Yes.
Maybe I'm getting vague, maybe because, but still, so 64 partitions are there. But let's say if I have a very big file, right, which will have many partitions, then will it keep on reading the partitions, or how
you will say it will have many partitions? Cluster is going to create it, right? So that is what next step here you see, this you understood, right? So driver program, all these things. Now you see here, you will come to know here, you see how it will do is you submitted your driver program. Okay, so Spark context is created. Step 2. Step 3 is you inside Spark context there is something is happening. What is that? It will have some unresolved logical plan, optimized logical plan. We discussed catalyst optimizer and physical plan, cost based model. It will extract all those things. Now here what is happening here is whatever code, like here you created RDDs, right? So these RDDs when you created it, basically when reading the data based on the number of cores in the cluster, it creates the tasks. How many tasks it has to create is it will decide based on the cores that you have available in the cluster.
Okay.
Okay.
Yeah.
Clear?
Yeah.
No, you need to be very confident. If you have any doubt, you just let me know, because I'll give some other examples to make you understand.
No, this I understood, but I still wanted to know that for 64 cores it can read based on that memory that we discussed. Only that much data it can read, right? But my confusion is that for partitions is based on memory. So
no. Based on the course, your partitions are created. Now the question is, let's say per partition, maybe the memory you are getting only 1 GB. Okay, 1 GB memory you are getting, and basically of 0.5 core, meaning one CPU is executing 2 partitions, and each partition should be 1 GB as per the given example, internal node internals. Okay, now your question is, if the file is very big, let's say it's 1000 GB.
Yeah.
In that case, if you divide it into only 64, so it may come approximately, each partition may come approximately more than 10 GB. That will not fit it into that that particular task and it will not be able to execute. No. What happens? Whatever data, excess data is there, that will spill out to the disk. It will not use the memory. It will spill out to the disk. That's why you need to take care of those things as well. You see, come back here. You see partition size, min partition size, minimum. So the partition should be 1 MB. It should not be less than 1 MB. If you create two small partitions, there is a problem. Similarly, max partition size also you can able to set, I think. Okay, meaning you are basically controlling the partition size. When you control the partition size, what is going to happen is, here you see advisory partition size in bytes. So you are advising, try to make the partition size of 64 MB. If we have a more data, like let's say you are trying to create only 64 partitions, but the file is very big. In that case, it will try to create 128, 256. The even number, it will try to create it. Or if it is not creating automatically, in Spark 3, it is automatically creating. But in Spark 2 and Spark 1, if it is not creating, based on our cluster size, partition size, we need to decide the number. That number must be an even number. Why even number?
So my question, okay, I understood this, okay, correctly. But just what I want to clarify is the default partition size is 128 MB, right, for the file.
No,
So
that
here
is,
in this case,
no. Wait. That is when you are reading the data from the HDFS, the block size is there, I think 128 MB. When you are reading from there, the partition by default, it will consider as a 120 MB partition. Okay, that is
here if we increase, then will it read that whole two partitions at one time and make it 256 here in this example at the same time? So what I'm saying is on HDFS it is 128 MB, right? But let's say when we are let's say here advisory partition size, if I set it as 256 MB, then will it go and read two physical partitions in one go and bring it? Correct?
Yes.
Okay. That was the confusion. Yeah, that was my confusion. Understood.
So what it will do in that case, if you are forcing a Spark to create a partition with a 256 MB. By default, it is trying to create a 128 MB partition, but you are overriding the behavior property. So when you override, it will combine two blocks to make a single partition.
Yeah. Okay. One question I have, that do we need to go and do this kind of setting in any normal scenario, or it automatically, like in most of the cases, no need to do anything, or it is okay to go with
most of the people will not do, but when you are handling with terabytes of data, whenever you have performance issues and all, you will come and check all these things. Otherwise, normal, see, most of the jobs, you know, right? So SD1, SD2 creation and file type conversion, small jobs we don't require. But when you are working for a very big organization and they are getting a lot of data daily and streaming data, so you need to tune some kind of a performance issues. In that case, you need to look into all these things. Okay. So now everybody understood, right? So driver program, basically you are submitting the code, then Spark context will be created, and then what happens is, along with that Spark context, the another side is the driver is requesting the cluster manager to allocate the resources to execute this task, whatever it is creating. So these tasks, so cluster manager will launch the worker nodes. Once the worker nodes are available, these tasks will be submitted on the worker nodes, and worker nodes will be return the result back to the driver program. Okay, so this DAG scheduler, catalyst optimizer, all those things, all those things we discussed as part of the training. Okay, so this DAG scheduler, everything like what is that? DAG also we have seen as part of the training, right? Then what we need to understand is Spark UI in depth. We need to understand in this particular training. Okay. Any questions here?
No, I'm good.
Yeah, let's move on. So life cycle of Spark application, if you see, user submit the application and it basically driver initiates the Spark context or Spark session, and DAG creates logical plan with the jobs, stages, and tasks. Tomorrow we are going to talk about so how many jobs are going to create, how to analyze how many jobs it is going to create, how to analyze how many stages it will create, how to analyze the task, how to analyze the stages. Anybody remember? How to analyze tasks, how to analyze jobs? Nobody remember? Y transformation. Nobody remember? Oh my God, what's this? I have given clue also. Y transformation, I'm telling. Okay, fine. So tomorrow we'll discuss. I thought like you people are aware of everything, and I am repeating the content in this interview question and answers batch. But seems to be I need to discuss everything again. Okay, you people did not remember when stages will create, when tasks will create, jobs, all those things. Okay, fine. We'll discuss again. Next. So once the job stages tasks are available, now to execute the task executor will request, that is nothing but a task executor which will be there as part of the this driver, which basically requests the cluster manager to launch the required resources, to assign the required resources. So cluster manager allocates resources to execute the task. So now driver establishes connection with the worker nodes and assign the task, whatever steps I discussed. Okay. After that, what happens? Workers will execute the task and it returns a result to the driver. So driver basically generates output to the user. Okay. Then Spark application in C. Clear? See, what I need is after today's session, you should be very comfortable in explaining the Spark architecture to the interviewer, or you also should be very flexible or comfortable in explaining the Spark architecture to anybody who is asking the Spark architecture, not only in interview. Maybe your colleague wants to learn, you to explain the Spark architecture. You should be able to explain them very clearly. Okay, fine. Now cluster sizing examples. If we take data analysis, okay. So data analytics typically perform the processing requires data from multiple partitions. Multiple partitions meaning, let's say we just discussed, maybe you are basically reading data from the very big file you read, and it creates multiple partitions, and basically you need to read multiple partitions, basically leading to many shuffle operations. When you are when you have a more partitions, when you apply group by join, what happens? What happens? It leads to shuffling of the data. Basically, there is a lot of shuffling is going to happen in the network. It basically causes what? Performance issue. So a cluster with a smaller number of nodes can reduce the network and the disk IO needed to perform this shuffle. Meaning, so instead of creating the too many partitions, okay, too many partitions, if we can able to create a very few partitions with the partition size is very high, then we can able to reduce the shuffling of the shuffling operation. So for that, out of these four, which one is best is, this is the best one. Okay, you see, one large computer, see the virtual machine type is X large, total VMs you are using is 1. VM type is large, total VMs you are using is 2. Total VM type is medium, total VMs you are using 4. VM type is small, total VMs you are using 8. Doesn't matter. See that this is the example I have given at the beginning of today training. So 50 GB per executor, 20 cores per executor. If you take total end of the day, your Spark size is going to be, Spark cluster size is going to be 400 GB, again 160 cores. This is the one combination. 8 missions, 8 small missions you are taking, one big mission you are taking, single big mission you are taking. Which one is suggested is, this is the one which is suggested. This one is suggested. Clear? Because if you have multiple missions, multiple cores, what happens is basically data should move from one mission to the another mission. That basically shuffles the data and it has a performance issue. Okay, whenever you are moving the data, try to reduce the number of compute nodes, the number of nodes in a cluster, and try to make the big nodes. Clear? This is next cluster sizing example. So basic batch ETL, simple batch ETL jobs that don't require Y transformation. What is Y transformation? Wherever data shuffling is required, like join, repartition, group by, reduce by, all these are Y transformation. What is narrow transformation? Filter, select with column, all these are examples for the narrow transformation. But I see nobody is remember anything. So see, Y transformations such as joins or aggregations, it can be anything. Okay, typically benefit from clusters that are compute optimized. So when you don't have a Y transformation, okay, when you don't have a Y transformation, what happens is you can choose any node. You can take a big node, you can take a small node, you can take a very small node. Any node you can take. There is no issue when you don't have a Y transformation. When you are not moving data from one mission to another mission, if you don't have such type of issue, you can go with anything, no problem. Okay, next, complex batch ETL. You will have more complex ETL jobs such as processing that requires union joins across multiple tables will probably work best when you can minimize the amount of data shuffled. So what you wanted to do is you want to minimize the data that you want to shuffle. Since reducing the number of workers in a cluster will help minimizing the shuffle, you should consider a small cluster. Why small cluster here? One second, there is a small problem in the, I think, diagram. Give me a minute. Cluster sizing. Yeah, so sorry. This is correct only. Yeah. So here again, what we are trying to do is we are trying to minimize the amount of data shuffle. To minimize the data shuffling, what you need to do? Again, you need to reduce the number of virtual mission. So that's correct only. Okay, I just confused. So again, we basically wants to reduce the data shuffling. Whenever you want to shuffle the data between the compute nodes, try to take a few missions which are big instead of taking the multiple missions. Because if you take multiple missions, what happens is when you are moving the data, when you are shuffling the data, it causes the performance issue again. So machine learning, if you want to train the machine learning models, basically you need to go with again highest to try to take a very big mission. If that is not available, take large, then medium. So meaning ultimately from all these cluster sizing examples, what you have to understand is try to take a minimum number of nodes which has more memory and more cores instead of taking multiple virtual missions with a multiple virtual machines with a few data, like a few cores and a few GB of data. What you can do is you take a less number of virtual machines with a high configuration of the compute, like 400 GB memory and 160 cores. Here we have in cluster D, we are using 8 virtual machines, 50 GB per executor, and 20 cores we are using. Clear? Yeah, that's all. So I think we discussed everything. Any questions?
No, Malaya. Malaya, I have one other question not related to today's session. So at the end, so I believe most of us are here like non-experienced and taking the coaching, right? So will you explain